Good morning, student. Jai Gurudev. So, in our last class, we have talked about your polydentate one. Polydentate ligands, we have talked about EDTA. So, this one is ethylene diamine tetraacetate. So, formula is your this is CH2 acetate ion CH2 COO, and diamine is this one. Ethylene diamine tetraacetate ion means tetraacetate, 4 acetate. So this is donor atom 1, this is donor atom 2, this is donor oxygen donor atom 3, and diamine. This is donor atom 5, this is donor atom 4. So this one become your hexadentate ligand. So this one become hexadentate ligand. So if I take your ambidentate one, in ambidentate one, if I take Cn negative, so in this case the nitrogen sometime become donor atom, sometime become carbon donor atom. So if it is bond with the carbon, so it become name is cyano, and this one become nitride. So with if donor atom become different, the names also turns to be your different. So like that we have to go for this one also. Now from this we are taking the two more term. One is your coordination polyhedron. If you have asked about that one, coordination polyhedron. So coordination polyhedron actually 3D structure of the particular complex. So if a complex is Ml4, the structure is like that. This is Ml4 tetrahedral structure. Trigonal bipyramidal, if Ml5, that turns to be your trigonal bipyramidal structure like this too. This is M, this is L, this is L, this is L, this is L, this is L. So these are the structures. These structures are called coordination polyhedron. Now if I consider another point that we are going to take today, this is your oxidation number of central atom. So oxidation number of central atom. Now if I have a complex like that, CO NH3 Cl2 positive. So this one already we have done. Central atom is cobalt is X, and molecule NH3 having no charge is 0. Cl having charge of -1 into 1 is equal to +2. X equal to 2 plus 1 become 3. So like that you have to find the coordination number central atom. Now if you consider the another one, It is K4 Fe CN6. You have to find the coordination number of Fe. There is no charge. You have to write 0 there. K4 potassium, we know that +1 carries +1 charge. So 4 into 1 plus X plus 6 into -1. So X equal to 6 minus 4 become 2. So this is how we have to find the coordination number of central metal. After coordination number, student, we take another point. This is called, this is actually oxidation number we have read. This one we have read about the oxidation number. Now this one is oxidation number, student. This one is oxidation number. So coordination number actually some different things that will take the coordination number next. Next one is coordination number. Coordination number. The number of unidentate. Coordination number Cn is equal to number of unidentate ligand attached to its central metal, or 2 into number of didentate ligand, or 6 into number of hexadentate ligand. So for example, if you require to find the coordination number of copper in this one, so it will be here 4, because these are unidentate ligands. So 4 ligands, 4. Similarly, if I want to find the coordination of number of iron in this one, so it will be, now C2O4 is a didentate ligand, and what is the rule for didentate ligand? 2 into didentate ligand. So if 2 into, it is 3 here, 2 into 3, so its coordination number become 6. Now if a complex takes like that also, student, it is become Fe in bracket PDTA. So it is 1, but it is a hexadentate ligand. So 1 into 6, its coordination number become 6. So these are your coordination number. Again, another point if you take, student, your complex compound is divided into 2 types of complex compounds are there. One is homoleptic, another one is heteroleptic. Homo means same. So if you have same ligands are there, then homoleptic. Hetero means if you have different ligands are there, heteroleptic. So for its complex, if it is CONH3 6 times tripositive, this is the homoleptic example. And heteroleptic complex, if I take CuNH3 4 times Cl2 positive, it is heteroleptic complex. This is different ligands are there, so it is called heteroleptic complex. If same ligands are there, this is called homoleptic complex. So student, whatever we have introduced, that one is up to this. Actually, we require to have the knowledge about your double salt and complex compound. Double salt is something which dissociate into constituent ions. Now if you have the example of your complex compound, the complex compound is something which does not dissociate into constituent ions. In double salt, the individual constituent ions property of a compound does not remain same in the solution, but in complex, the complex part property retains. Now, in double complex compound, coordination compound, double salt, we have coordination bond. In double salt, we don't have coordination bond. Actually, in complex compound, we have primary, secondary valency. In double salts, don't have primary, secondary valencies. We have learned about the primary, secondary valencies. Primary valencies that remains in outside the bracket that involved in ionic bond with the complex part. In complex compound, we have all the coordinated bond are of complex compound. With that, we have learned about the ligands, different types of ligands. So then we have learned about the oxidation number. We have learned about the coordination number. So student, you require to do all these things. So up to this, today's student, try to get all the knowledge properly.